Hello friends, today I talk about game theory in the context of prisoner's dilemma problem. This is a blog from Medium by Mr. Shankha Mandal from Indian Institute of Science, Bangalore. Imagine you are at a table playing a board game. Every decision you make impacts not just your outcome but also your opponent's. Each move requires careful thought as you weigh your options against your rivals' potential responses. This back and forth creates a challenging situation where planning and strategy are crucial. This is the essence of game theory. Here, the term game is a metaphor for real life scenarios such as business negotiations, geopolitical treaties, and social interactions. So, this is a discussion on game theory. This fascinating field examines how individuals and organizations make decisions in situations where their choices dictate the outcome of a game. Game theory provides valuable insights into the decision-making dynamics where players or stakeholders behave rationally. It helps understand how cooperation, non-cooperation, conflict, and competition between players participating in a game shape our world. So let us talk about prisoner's dilemma problem. Imagine two individuals, Kratika and Ishita, accused of espionage and arrested. They are taken into separate rooms for interrogation so they can't communicate. The police authorities don't have enough evidence to convict them of spying against the nation's interest, but they offer each of them the same deal. If both remain silent, they will each receive 2 years in prison. If one confesses and the other remains silent, the one who confesses will go free while the other will get 20 years in prison. If both confess, they will get each 7 years in prison. We can represent the information in a payoff matrix where the first number in each pair represents Kratika's outcome and second represents Ishita's. The values are negative because a lower number indicates a more favorable outcome, few years in prison. So this is the payoff matrix. Kratika remains silent, Kratika confesses, Ishita remains silent, Ishita confesses. Best is -2 if both remain silent and get away with 2 years in prison. Now Kritika is contemplating her options. She thinks, if I stay silent, I could get either 2 years or 20 years, depending on what Ishita does. But if I confess, I could either go free or get 7 years. Confessing gives me a lot of freedom. But if Ishita is thinking the same way, the dilemma puts Kratika and Ishita in a tough position. In game theory, the scenario is called a prisoner's dilemma problem. If they both trust each other and remain silent, they will each get 2 years in prison, a relatively mild sentence. However, the fear that other might confess, especially since spies have trust issues, could lead them to betray each other. This would result in both confessing and getting 7 years each, which is worse than if they had both stayed silent. The rational and self-protective choice for Kratika and Ishita is to admit to the crime, but this leads to a worse outcome for both. They ended up confessing. This is known as Nash equilibrium in game theory. So let us talk about Nash equilibrium. Nash equilibrium is a situation in a game where each player selects the best possible action based on the knowledge of what the other player are doing. When players reach this point, no one can change the decision to achieve a better outcome because their current choice is already the best response to the actions of the others. Kratika and Ishita understand the potential choices. As they have access to payoff matrix, they aim to select the option that benefits them most. Once they both make their choices, if neither can improve their outcome by changing their own decision, that is called a Nash equilibrium. So it's a stable equilibrium. In this scenario, even though it would be better for both of them to remain silent, resulting in only 2 years in prison if they both confess. The reason is that if one chooses not to confess while other confesses, the silent person faces a significantly worse outcome of 20 years in prison, so that confessing becomes the safest choice. The Nash equilibrium in this case is both confessing, as neither Kratika nor Ishita can improve the situation by changing their decision. They are effectively stuck with the choice, even though it is not the best outcome. This irony is that This irony is that Kratika and Ishita acted rationally and didn't cooperate. They didn't trust each other, leading them to serve 7 years in prison. They would have been imprisoned only for 2 years if they both cooperated, trusted each other, and stayed silent. This is a paradoxical situation. Some real life examples: Kratika and Ishita could be working on a group project. They are jealous of each other. They can achieve a high grade together if they put in equal effort. However, if Kratika does all the work while Ishita slacks off, Ishita may still get a good grade without contributing. The same applies if the roles are reversed. If both don't give their best to do minimal work, the project will fail and both will receive poor grade. There are many scenarios like this. Kritika and Ishita could be CEOs of two competing food delivery platforms in the same area. Kritika and Ishika could be heads of two countries contributing significantly to global emissions. Kritika and Ishita could be heads of two countries developing nuclear weapons, etc. They could cooperate by trusting each other and deciding not to spend billions on arms, instead using funds for public welfare or infrastructure. But fearing the other's intentions, they choose not to cooperate, spending vast sums on nuclear programs, money that could have been used for more productively elsewhere. This happened between USA and Soviet Union in the second half of 20th century. During Cold War era, USA and Soviet Union, now Russia, were locked in nuclear arms race. Even feared that other would gain a military advantage. Both nations continued to spend billions of dollars and build thousands of warheads, even though cooperation and trust could have reduced tensions and military spending. So this chart starts from 1950 to 2014, and as shown in the above plot, the US and Soviet Union stockpiled nuclear weapons throughout the Cold War until the Soviet Union's falls in 1991. So after 1991, Soviet Union reduced its cost in military services. Interestingly, both superpowers now have fewer warheads than 1960s, 70s, and 1980s. Had they chosen to cooperate earlier, they could have avoided years of intense arm buildup and redirected resources towards other priorities. Although the tensions between US and Russia are currently high due to Russia's invasion of its former territory Ukraine, they somehow realize the benefit of cooperation. In real life, interaction between parties aren't always one-time events. Surely, Kritika and Ishika, two spies, faced dilemma, once ended up serving 7 years in prison. But in a parallel world, Kritika and Ishita face the same dilemma in terms of pricing day after day as the CEOs of two competing food delivery platforms. There are many parts on game theories. I'll stop here. Thank you.